3, 2, 1, ignition. On September 5, 1977, NASA launched something that was never meant to come home. Not a rocket, not a satellite, a message in a bottle. A machine made of metal, gold, and circuits thrown into the cosmic ocean on a one-way trajectory. Today, decades later, Voyager 1 and Voyager 2 are still flying. They are the most distant human-made objects in existence. But almost everyone tells the Voyager story like this. They went far, they sent pictures, one day they'll shut down, and then the mission ends. That's the comforting version, because the real version is stranger, and honestly, more unsettling. Because the end of communication is not the end of the journey. It's the moment the real journey begins. When the last signal fades, Voyager doesn't stop dying. It stops being a spacecraft and becomes something else. A drifting artifact, a silent monument, a human fingerprint that keeps moving long after the hands that built it are gone. So in this video, we're not focusing on the past, Jupiter, Saturn, Neptune. We're tracing what comes next. Where will Voyager be in 40,000 years, in 300,000 years, in 1 billion years? And what happens to a human-made object when it's left completely alone in the endless dark between stars? Part 1. The Voyagers are dying, but not how you think. Voyager 1 and 2 aren't failing because something broke. They're dying from something colder. Energy starvation. They run on RTGs, radioisotope thermoelectric generators, basically a power source that turns heat from radioactive decay into electricity. And it's brilliant, but it's not forever. Every year the fuel decays. Every year the available power drops. And NASA has been doing the work of a surgeon, turning off heaters, instruments, subsystems, one by one just to keep the heartbeat going a little longer. But the math doesn't negotiate. Sometime in the 2030s, there won't be enough power to keep the transmitter running. And that's the moment the world will hear the headline, Voyager has gone silent. And most people will assume that means the story ends. But silence isn't an ending. Silence is a transformation. Because when Voyager stops talking, it doesn't stop moving. It keeps flying at tens of thousands of miles per hour in a vacuum with no friction, no air, no weather, no rust. Just motion. Just time. Just the long drift forward. Part 2. Interstellar space doesn't mean out of the solar system. Here's the first reality check that makes people uncomfortable. You've probably heard that Voyager already left the solar system. And you've also probably heard the opposite. No spacecraft has truly left the solar system. Both can sound true because people are using different definitions. Voyager 1 crossed the heliopause. Voyager 2 crossed it later. The heliopause is the edge of the solar wind bubble, the region where the sun's charged particles stop dominating and interstellar space begins. So yes, Voyager is in interstellar space, but gravity doesn't care about headlines, because in gravitational terms, Voyager has barely left the yard. To really leave the solar system in the deeper sense, you'd have to escape the sun's farthest realm, the vast shell of icy debris that surrounds us like a cosmic fortress, the Oort Cloud. The Oort Cloud is so enormous, it's hard to even call it part of the solar system in a normal way. It's like the sun's final whisper, tens of thousands of astronomical units out. And Voyager is still heading towards it, which means even after the last signal, even after the last instrument, Voyager will still spend thousands of years moving through what you could call the sun's haunted outer territory. Not racing, not exploring, just drifting through a comet graveyard. That's the first terrifying truth. Voyager will outlive its mission by an amount of time the human brain doesn't handle well. So picture the moment. It's the 2030s. Voyager's transmitter finally shuts down. No more data, no more faint radio whisper, no more connection. At that moment, Voyager becomes a ghost ship. Not in the Hollywood sense, not crashing into things or triggering alien wars. The real horror is quieter. Voyager becomes an object that will keep moving, even if nobody remembers its name. It will drift through darkness so cold it makes Antarctica feel warm, temperatures approaching the cosmic background, just a few degrees above absolute zero. And yet, because space is mostly empty, Voyager will likely remain physically intact for a very, very long time. No wind to erode it, no rain to dissolve it, no oxygen to rust it, just tiny impacts from dust grains over unimaginable timescales. Cosmic sandpaper, slow, patient, unstoppable. 40,000 years from now, the first near miss with a star. Now we jump forward to the first milestone that sounds like fantasy. 40,000 years. If you say that out loud, your brain treats it like mythology, but 40,000 years is just time. By then, everything you recognize about human civilization is likely gone or unrecognizable. And yet, Voyager will still be moving. Voyager 1, in roughly 40,000 years, will pass relatively close, astronomically speaking, to a star known as Gliese 445. Close here does not mean close in a human sense. It's still about 1.6 light-years away at closest approach, which is near only if your scale is the Milky Way. And that's what makes it eerie. Voyager 1 will have its first stellar encounter, and it won't even know it happened. No cameras, no transmission, no human applause. Just a dead machine gliding past a distant red dwarf, like a bottle drifting past an island with no one there to read the label. Meanwhile, Voyager 2 has its own future meeting. In about 40,000 years, Voyager 2 will pass within roughly 1.7 light-years of Ross 248. Again, not close in a human sense, but close enough that it becomes a cosmic waypoint, a reminder that stars move. The galaxy is not a frozen map. It's traffic. Everything is traveling, even the things that look fixed. Now we push forward again. Hundreds of thousands of years. This is where time stops feeling like history and starts feeling geological. In roughly 296,000 years, Voyager 2 will pass within a few light-years of Sirius, the brightest star in Earth's night sky. Imagine that scene. A small probe built in the 1970s, bathed in the glare of a star that humans once used as poetry. And it will still be silent. No voice. No message, just motion. This is what makes Voyager disturbing. It turns time into something physical. It forces you to picture the future not as a concept, but as a place your artifacts can actually reach. Here's another misconception. People imagine Voyager will just keep going forever until it escapes everything. But it won't. Voyager is fast by human standards, faster than a rifle bullet in some comparisons, but the Milky Way is massive. Voyager does not have the speed to escape the gravity of the galaxy, so Voyager's fate isn't freedom, it's something weirder. Voyager becomes a permanent citizen of the Milky Way, a tiny artificial comet on a gigantic orbit around the galactic center. It will drift through spiral arms, through thin clouds of interstellar gas, past the birth and death of stars. And here's the scale breaker. One full orbit around the Milky Way, the so-called galactic year, takes roughly hundreds of millions of years. Voyager is stepping onto that clock, a clock that doesn't care about human lifetimes, or empires, or even species. And this brings us to the most haunting cargo Voyager carries, the Golden Record, a gold-plated copper disc attached to the spacecraft, designed as a time capsule, not as an invitation, more like a proof, a piece of Earth you can hold. It contains sounds of our planet, nature, human life, music, greetings in dozens of languages, images of our anatomy, our cities, our science, our everyday existence. And even if nobody ever finds it, the weird part is this. The Golden Record may last longer than Earth's civilizations, possibly longer than Earth's surface monuments. Given enough time, plate tectonics erases cities, erosion grinds mountains down, climate and chemistry rewrite the planet. But Voyager, floating in vacuum, has a chance to preserve a snapshot of us as a physical object for a span of time that makes human history look microscopic. And that creates a brutal paradox. A machine built by a temporary species might outlast the memory of the species that built it. So here's the true, terrifying truth about the Voyager journey. It's not the distance, it's not the cold, it's not even the silence. It's what it reveals about us. That our greatest creations don't arrive, they drift. That the universe is so large that even our best effort becomes a moving speck, a cosmic breadcrumb that may never be witnessed by anyone. And yet, that's also what makes Voyager beautiful. Voyager is proof that a creature on a small rock can look into the dark and say, "Still, I want to send something." Not because we're guaranteed success, not because we'll conquer the galaxy, but because curiosity is a kind of rebellion. Voyager is not a ship, it's a gesture, a signature, a quiet defiance against being invisible. So when you hear that NASA has turned off another instrument, when you see the headline that Voyager is ending, don't picture a death, picture a graduation. The mission of planetary exploration ends, and a much stranger mission begins. Voyager becomes an artifact of the Milky Way. And long after we're gone, it will still be out there, moving through the great cosmic night, holding a golden disk of Earth, like a fossil of feeling, waiting for a universe that may never notice, and traveling anyway. If you could send one object into deep space to represent humanity, what would you send? A message? A memory? A warning? Tell me in the comments. And if you want more videos like this, deep time, cosmic scale, future reality, subscribe to Beyond 2200. Because the scariest truths aren't always monsters. Sometimes they're just numbers.